Hi everybody, it's Kyle Houchins. I'm Tech and a Trainer for McNeil, and I'm here to talk to you about some features in Rhino 8. The two that I want to talk to you today go hand in hand. One is called Inset, and it's for manipulating curves and insetting curves on surfaces. And the other one is called Push-Pull, which is a new feature that we're implementing in version 8 that allows you to do some kind of quick massing type of modeling moves, and it was originally intended kind of for architecture and for the architecture space, but I've actually been messing around with it a lot, and I'm finding it has a lot more uses other than just architecture. So let's just jump into it, and I want to show you a few things. So let's run the inset command, and for the purposes of this video, I'm gonna use hotkeys just for speed's sake, but the command is actually inset, and let's run it. The first thing it's going to do is it's going to ask us to select a face or an n-gon. And I'm going to just pick a face, I'm going to highlight it, I'm going to right click to accept, and you'll notice that it starts dropping a line on here. Now, we've got some options in the command line here. One is called through point, and that allows you to interactively drag the curve. The other one, ignore seams and split yes or no, gives you the flexibility to be able to edit these curves on the fly. For now, we're gonna ignore seams. Split, basically what happens if we set split to no and we run it, we just end up with a curve, right? And nothing's changed about the surface. If we do it again and we turn split to yes, what's going to happen is it's actually going to automatically split the face. You can see that we actually have individual, face segments within this polysurface. It's still a polysurface. It's not been split up into separate objects, but it has been split up into faces. So this would be essentially the same thing as if you were to run the split face command. And we'll talk about why that option is there in just a little bit. But let's look at a couple of different scenarios where inset is particularly useful, whereas something like curve offset wouldn't necessarily do as good of a job. So let's run the command again. Pick the face. And I'm going to just hit the T key and right click, and that's going to bring me into through point mode. And you'll see as I drag, what happens is the curve kind of interactively decides what regions it's going to keep, and actually does a curve boolean to be able to provide the result, right? And so if we do something like this, we can go ahead and run that, and it's going to split. If we do something like this over here, you can see that as you go, it's going to interactively kind of go in or out. If we do something really severe, you would notice that an offset would actually create a self-intersecting loop and would create something that's not super useful. And you can see some little artifacts down here in the corner. Those are just display artifacts. When we finish the command and run it, those disappear. And you can see that we end up with these different regions. Now, if we look at something practical, like maybe we're going to inset text, let's run it again. We're going to pick a face, and I'm going to hit the T key, and we're going to just drag, and we're going to decide kind of what kind of inset we kind of want. And I'm going to put something about there. Now, the cool thing is, if I do this command again, if I just click, right click, it's going to give me the same value of offset. So let's do it again. Click, right click, right click, right click to invoke the command again. Click, right click, right click, click, right click, right click. Then I get even offsets through all of these little pieces. Now, once we've got this offset, we can use the new command in Rhino 8 called push-pull. And for the purposes of this video, I have a hotkey set up for it, but the command is actually push-pull. And we're going to just select a surface, and we can just pull it up or down, right? Very simple, right? But the cool thing about it is if we pull up, it adds to the part. If we pull down, it subtracts from it. And that's really cool. That's really gives you a lot of options. So we can do the same thing here. We can pull that down and it disappears, or we can pull it up and add some detail to this piece. Okay, same thing here. So now let's look at the text, and we want to recess the areas that we inset to create, some detail on the text. Now, if I pick this and I run push-pull, you'll see that it only allows me to pick one piece of this. And that's fine because I can set my direction, and then I can left click to set the direction, and then if I want to repeat that, pick, drag it down, but don't left click. We're just going to right click, because what we want to do is we want to set the direction, because what it does is it remembers the height, but it doesn't necessarily remember the direction. So I'm going to run it again. We're going to pull down, not going to left click because we don't want to set a new direction, and then I'm going to hit my right click to accept. Same thing over here. We're going to drag down and we're going to right click, and it's going to drop it to the same level. And we can do that for the rest of the parts. But the thing that I wanted to point out is in situations like this R where we had to make 3 clicks, this is, I'm going to go backwards a little bit here. Let's go back and let's actually uninset this, and let's hide everything else and just focus on Rhino for the time being. If we go back to Inset, and I talked about the option for Inset, which is this split yes or no. If I set split to no, and then I go through point, and actually we'll just go ahead and accept that. We're going to run it again, and we're going to run it again. And we get essentially the same layout we had before, but instead of splitting the faces, we've actually just left the inset as curves. Now, what push-pull does, and there's a little artifact here that I don't like, so I'm going to just delete that. But what push-pull does is it looks for regions, and if it's an absolute split, if it knows it's there, then it doesn't give you any option to choose. But in a situation like this where there's some ambiguity, what it does is if I pick these 3 pieces, but I want to pick something different, I can invert it, right? And I can do that in the command line. Now, the cool thing about this is if I want these 3 pieces, and let's say that this is broken up into 50 pieces, right? That would be really challenging to go through and click all of this stuff. What I can do is I can pick the surface that it's not, invert, and then I can drag and do my push-pull, and I'm going to set that there. Now, so if we continue on this and we look at the H where we've got 2 distinct regions, we can run push-pull, we can click the surface we don't want, it highlights, hit I, enter, it gets the surfaces that we do want, and we drag down. Now, we can use O-snap, we can snap it to the same distance, right? And once we have that distance set, or copied, or whatever you want to do, you can then just proceed as you would like. Like we can do new things, or change the height, or change the depth, or whatever. But that invert allows you to be able to, on things like this O, where you've got 2 distinct regions, you can pick the region, invert, and then affect the opposite of the thing that you pick. So sometimes it's easier to pick the big surface and then invert into lots of little pieces or surfaces or things like that. So that's kind of like, a primer for inset push-pull. So let's look at inset and push-pull, how they're used in practical application for something simple. So let's start with a box, and let's try and turn this into something a little bit more interesting. And for this case, what we're going to do is we'll do some standard kind of split face stuff and show you how it all kind of fits together. So let's just draw a curve right down the middle here. And let's split this face. Use a curve. And you can see that we end up with 2 individual faces. We can just do standard gumball modeling where I control shift and then drag with the gumball to get the shape of a house. Now the cool thing about this is we can then take push-pull and turn this into something a little bit more interesting. Now, another thing that's been added in Rhino 8 is auto C-plane, and auto C-plane responds to sub-object selection. So say for instance if I wanted to draw a front door and a couple of windows on this face right here, if I turn auto C-plane on, click this face, you'll notice that the C-plane automatically aligns to that face. I can then start drawing shapes right on that face, and everything that I draw is going to stay on that face as I draw it, right? Now, once I've done that, I can then go to push-pull, and I can just pick these regions, and I can start detailing this just as I would with any other standard, push-pull operation. And that's pretty cool. So the other thing that push-pull allows you to be able to do is if we sub-object select, you'll see that there's this little icon out here. There's a couple of things that we can do with push-pull. I can grab an arrow and I can move the face, and you can see that the whole thing is going to adjust. Or I can grab this little icon right here, and it's actually going to extend or retract the surfaces based on that drag. So I can do things like that, right? And so I can, with a combination of push-pull, sub-object selection, gumball move, all that kind of stuff, I can start doing some pretty interesting things. So say, for instance, if I wanted to change this roof line, I can Control-Shift-Click. I can drag this over here, same thing over here. I can pull this straight down. I'm going to turn auto C-plane off for the time being so that it aligns back to the world. And then I can push-pull a face, and I can either add to it like this, or using gumball with auto C-plane, I can extend that surface like that. Now, let's look at something a little bit more complicated than this, because this is a fairly simple example. You would expect it to work on kind of a planar object like that. So let's look at something a little bit more complicated. Let's see what we can do with this. And there's a couple of fun things that I've been playing with while I've been testing this, and one of them is a sphere. And if we just start with something, and let's say we wanted to do some kind of like science fiction-y kind of detail. And the cool thing about push-pull, and I'm going to focus mostly on push-pull from here on out for the rest of the video, but the cool thing about push-pull is it respects curve on surface. So let's go to the top view, and let's just do something like this. Let's project a curve in that direction, and we're going to project a curve in this direction. So let's get these two, and let's just trim them for now before we project them. I'm going to use curve boolean, and we're going to just keep that, and then we'll project this onto the model, and we can delete the original curves now. And you can see that we have a shape like this. Now, the cool thing about push-pull is it's not just for planar stuff, right? I can run push-pull, and I can pick a piece of this surface, or I can invert. Actually, let's do it this way. Let's pick this part and then invert and then accept, and then let's pull this out a little bit, and it's red if it's going in, and it renders if it's coming out, and we can just add some detail to this thing like that. Now, we've got kind of our base detail, right? That's kind of cool. So let's use Inset, and let's add some additional detailing to this thing. So let's just do something like this, and I feel like that's kind of a good place to start. So I'm going to accept that. Notice I'm not splitting, and then I'm going to just click, right click, re-invoke the tool with a right click, click for the surface, and then right click to accept. And it copies that first setting around to the rest of the details. So now I can run push-pull again, and I can start playing with this and say, well, maybe I want to go something like that. So I can start playing with this, and I can start adding details. So let's continue. We're going to pick this section, we're going to drag in and right click, pick this section, drag in and right click, and then we've got some details like that. Now, it gets even more fun, because we can start doing things like coming in here and going to chamfer and we're going to chamfer a face edge. So we're going to get all of the face edges. So I'm going to pick this one, and this one, and this one, and this one. And we're going to go here, and we're going to preview, and this is going to look like a mess because this is way too big. And we're going to set the distance for all of this stuff. It's going to preview. It's going to go crazy on me. That's okay. And let's set all to something smaller. Where we start to add some interest by breaking those edges. Now the cool thing about this is actually going to create more regions that we could then inset and it insets inside the lines that we already chamfered. And remember, it uses that last value, so all I have to do is run the tool again, pick the surface, and right-click, and it gives me a symmetrical result. So now I can run push-pull again. It's going to find that region, and I'm going to pull outwards this time. And then I'm going to just follow this around and actually go this way. And then I'm right-clicking. I'm not left-clicking because if I left-click, I'm going to set a new depth. So I'm going to start dragging, and then I'm going to right-click because that's going to use the last stored value. And the reason that I drag it to start with is you can actually use the last stored value to go negative or positive. I want to go positive, so I'm kind of over accentuating on the positive, and then right-click, and that way it understands that it needs to go in or out. So that's pretty cool. We can start doing stuff like that. So what if we were to combine this with something else? Like, let's say we were to add another object to this. We could add, say, a ring to the center of this thing, and I'm going to just use gumball to snap this to the middle. I can Boolean this together, and then I can use chamfer face. I like this face edges option because let's go a little bit bigger. Because it gets everything in one shot, so for detailing and stuff like this, it starts getting really cool. Now, what if we wanted to do something that wasn't just a straight inset? So let's go to the front view, and let's do a detail. Let's make a cool little detail like this. And then let's do a polar array. So you're not limited by only what Inset gives you because of the fact that you can create and project your own curves. And so let's make this 8. Let's grab all this and curve Boolean, and we're going to trim all of that so that we get this little detail. And let's take this and let's stick it here, and let's stick it here, and then let's go like that. And then let's just set it out here in space, and I'm going to project it onto the model. And you might be asking, why don't you array it first? Well, because I don't have to. I can array the projection. Go to top view. And let's array this, I don't know, 15 times. Something crazy like that. And I've ended up doing the exact same thing that Inset does by placing a curve onto the surface. Now the cool thing about that is I can push-pull, pick this surface, and notice it's noticed the regions, right? Because we haven't split it. It's not, there's no ambiguity there as far as the selection is concerned. So if I invert, I get all of these guys, and then I can do something like this. I can just add these little details like this. And they all happen all at one shot, which I really like. This is a difference between like extrude face and push-pull. And we get a result something like this, right? Which is pretty cool. Now, we've got additional regions here. So if we run Inset again, look what happens. So we can use Inset on this face in order to get these regions for additional detail. And you can see that it's picked up that little bit of that edge there. So let's push-pull that. We're going to select this surface to push-pull. Actually got the wrong one. So we're going to select this surface to push-pull. We're going to invert, and then we're going to push these in just a little bit. You got to kind of pay attention to where the drag line is. It's back here. I don't want to go crazy. And you can see that we end up with that additional detail added to the model. Now, we had talked a little bit about the seam for Inset, and the thing that I want to talk about, this is the seam for that particular surface, and that could cause issues with Inset. So let's run Inset again. We're going to select this as our face, and then we're going to ignore the seams, because without ignoring the seams, you can see what it does is it actually insets, it takes the seam into account, and we don't want that. So we're going to ignore the seam. And in this particular case, we're going to set split to yes, because sometimes the seams can complicate the region. And we're going to push-pull this, and you can see we can just drag this out and add additional detail here. So you can see that Inset and push-pull allows you to very quickly be able to add details to things, whether they be custom shapes or whether they be, you know, derivative from the stuff that's around them. But it allows you a lot of flexibility and a lot of power to be able to create details really quickly. For the last little bit of fun, we can take this object that we've created pretty quickly, throw a few materials on it. I built a few here. We can drag this. We can go to these. I'm just Control-Shift clicking. And then we'll add some little glowy bits. We'll go to our rendered view, take a look at it. If we go to our render properties, we're going to use some of the new environmental presets. I'm going to use the industrial design colorful. I'm going to crank the brightness down just a little bit, and then let's go ahead and just run a render and see what it looks like. Go to the post effects. I'm going to turn on the NVIDIA denoiser. I'm using an NVIDIA card. And you can see that the image clears up really, really quickly. We're at about 21 seconds here. And I would say that that's probably good enough to get sign off, at least from the people that I'm working with. I'm going to just go ahead and pause it. We can come up here, right click, capture viewport to file or capture viewport to clipboard, create an image, and then we're ready to run off to a client review. Hope this gives you a little insight into some of the new tools we're developing for Rhino 8. I encourage you to give them a try. If you have any comments, please visit us on the forum, which is discourse.mcneil.com, and let us know what you think. Thanks a lot. My name's Kyle Houchins, tech and a trainer for McNeil. Go make great stuff. Thanks. Bye.